It will be a short course class. You know, originally, I was planning on adding another pattern to today's lecture. And then I remembered being a student, and then you get to towards the end of the semester, and the course is behind schedule, so the instructor sort of sped up, right? And so last week, did I cram all this stuff into the course so I could cover it in the final? And I was like, no students like to have, this course sort of sped up just to cover materials in an exam. So I decided you probably have enough material to study for the exam next week. And so we'll cover the final topic on metrics. And then on Tuesday, we'll have review. So you want to bring your questions. And then next Thursday, we will have the exam. The exam will be online. I expect you to do several things. One is I want to you need to log into the Canvas course for the class. And you'll download the exam, and you will then enter your answers and produce them either in a Word document or a PDF document. So I'm assuming everyone has either access to Microsoft Word or an editor that can produce PDF. And then you upload your exam to Canvas. I also expect you to have Zoom on, showing how you're working. If you don't have a webcam on your computer, Zoom does work on cell phones. And I'm pretty certain all CS students have a cell phone. Any questions?
Are we allowed to use notes?
No. Okay, let's get started then. And the ritual, sharing the screen. Come on. No, there we go. And then I have to rearrange. I've got issues. I've got two monitors. And whenever I share my screen, it wants to put all my Zoom windows on my smaller second window, which is down there. And when the window's down there, to see you, I have to look like this, but my camera's over there. So it's like, look, I like to pretend at least I'm looking at you, right? So I have one window, number two window, and then for chat. Okay. Now I'm back and ready to go. So on slide 77. So we've been talking about coupling cohesion. And all along we've been talking about, making code more flexible, on object-oriented programming. We want about code reuse. This is yet another way to talk about the same sort of thing. Right, and as they say, dependencies make code rigid. And so, this comes from an article, if I remember correctly, from Robert Martin. And they use this example. We're trying to write a program which will, read text from a keyboard and then output it to a printer or write to a file, copy it. And they're using that, again, as one of these very simplistic, simple examples to illustrate an issue. And the problem is, we have to be careful because, if our code gets tied to reading from the keyboard and writing to, say, a printer, now our code is coupled together, right? Our copy program is dependent on the keyboard and the printer. And then we're sort of stuck because now if we want to use any of the components anywhere else, we can't because they're coupled together, they're tied together. And so they want to find a metric to help us measure this dependency. And so then they say, well, look, if you read Design Patterns book, they say program to interface, and that reduces the coupling. And so they say, yeah, what we're going to do is let's create a interface for a reader and an interface for a writer. And then our copy class or program can just interact with that interface, right? Ask the reader to give me text. And now we're coupled to that, but anything that implements that reader interface can be used in the copy program. This copy thing can be moved elsewhere and use other readers and other writers, not to a keyboard or to a, well, that shouldn't be reader, that should be, writer. Right. And so it says this is more flexible in several ways. One is, yes, we're still coupled, copy is still coupled to reader and writer, but those are stable, right? Once we have the interface, we can subclass it or implement all we want. And so the reader and writer interfaces are not going to change as much as the details of how to read from a keyboard or read from a file or read from a network, right? So if we, think about the, design patterns, program interface, we're more flexible because the interface is more solid. In this case, he's talking about, well, he's considering these class reader and writer stable because they're not going to change much or at all, right? So they're using this idea of a stable class. Right? So, then they say, well, look, when you depend on other classes, changes those classes can affect you, right? So the fewer classes you depend upon, the stable you're going to be, because changes, there are fewer changes that could cause you to be changed. So far, so good. So then they divide classes into the categories. So a category basically, look, you might have some classes that depend on each other, are couples, so we'll make them in a category. And so we know that those classes have to be used together. So we can sort of treat them as a group. Right, and so we're going to reuse them. And these classes in this category or group, keep on seeing the same idea, right? Share some common function or achieve some common goal. But that's the same thing we said about classes, right? A class should be cohesive in the sense that they should represent one abstraction, achieve one goal. So they're basically taking this idea of a single class and applying it to a group of classes, right? We want these classes are together because they achieve some common goal. And so now we want to group these things, classes, into these categories or groups. And then we can talk about, all these groups cohesive, right? So now we finally can come to the metric. And so there's, right, two measures. One is if I have this group of classes I've categorized, how many classes outside of this category depend upon classes inside, right? And the other one is, the reverse. How many classes enter a group depend upon classes outside the group. And finally, we get this crazy metric. And so what does it mean, right? So we can think of several different extreme scenarios. One scenario is the classes in a group do not depend upon any class outside, right? What does that mean? That means that this group of classes will not be affected by any change in classes outside the group, right? And when that happens, CE is 0, so its instability metric will be 0, which means it's what they call maximally stable, meaning that we don't have to worry about outside changes requiring changes to classes in our group. Clear? So that gives us, right, instability equals 0. How do we get instability being 1? The only way to get it equal to 1 is if CA is 0, So no one outside this, no classes outside this group depend upon, right, classes in the group. But we do have classes in our group that depend upon classes outside the group. And then in that case, they say it's maximally unstable, meaning that that's the worst situation because now we have dependencies. Our group of classes depends upon things outside, and changes of those things outside can affect the group. So far, so good. And so we can then start looking at treating each one of these packages as a category and then compute its instability metric.
Is that typically what's done, or does a human usually decide what classes are a category, or is it done by package? Or
the problem with these metrics is if you do it by hand on a large project, it's not going to happen, right? So then, yeah, here they're doing it by package. And is that the best way of doing it? Probably not. But if we have, like I said, if we do it by hand on a large project, you might do it once, you might do it for a while, but once you start getting busy, that's going to be one of the first things that gets dropped, right? Now, we can see, right, the examples is one. And that makes sense because examples is just showing you how to use code and other packages, right? And no other package is going to depend upon examples because it's just showing you how to use other packages. So that value makes sense. The JSON one is 0, and that makes sense too because it's just a package to deal with converting objects to JSON and taking JSON and getting objects back out, right? So that's a fairly low level thing. And right, so it's not going to depend upon anything else. It's basically the lowest level. So it's a 0.
I'm having a little trouble understanding how the afferent coupling reduces instability because you have CA in the denominator for that equation.
So the question is, let me get rid of some of this. I'm going to do it that way. Yeah, so the question is, how does CA affect it?
I can understand the equation. I can't connect it with the Y. Like, why does that reduce instability?
Well, think about it. There's two extreme cases. one extreme case is like the JSON library. That library does not depend upon anybody else, and everyone else depends upon it, right? And so in that extreme case, all dependencies are going to our package, and so our package is basically independent, right? The other extreme is like the examples, right? And examples only depends upon other classes, and the classes inside the example don't depend on each other. So the idea is the more you depend upon things outside your outside your group, the less stable you are, and since you depend upon other things. And so we're trying to measure the difference between how many things you depend upon and how many things depend upon you. So it's the idea that the more things that depend upon you, it's likely that there are fewer things that you depend upon. So when you think of the two extreme cases, it sort of makes sense. In between, it starts to get fuzzy, right?
Yeah, definitely. But that helps. Thank you.
And it's, like I said last time, these metrics, the way you want to use them is just as a tool to help you find spots in your code that you should look at to examine to see whether or not you should be refactoring them or not. Right, and so they talk about how to be flexible and stable. How do you want to be able to change and be stable? So they want a measure of this abstractness. And so they get this another metric where it's the number of abstract classes in the category versus the total number of classes in the category. And the goal then is to find the right balance. Clearly, if all classes are concrete, then there's no abstract classes or interfaces. So whatever we use, we're coupled directly to the concrete implementation. So that's not so good. If everything's abstract, that's also not so good because you're not doing anything, right? It's just interfaces. So then you define this main sequence. We have abstraction and instability now, and right. So for abstract, our instability is 0. If everything's concrete and we're completely unstable, right? They draw this line between those two, and we call that the main sequence. And now they want to say how far away from the main sequence. And they're suggesting we don't want to get too far away from that main sequence. And so the claim is that if we're not near that main sequence, that category may need some improvement. And again, looking at some examples, right, so number close to 0, so examples is a 0. Org.json is closer to 1. Now, dealing with these metrics, like I said, there are tools to help us guide us what may or may not be, should we look at? What are our valid values that we can accept? Often we have to, go by experience. Which metrics do we want to use, look at? Depends upon the company and the project you're working on. One metric that some agile processes use is they write down basically what they call a story or functionality, a small piece of functionality you need to implement, and then they basically have a room where they post all the stories. And then as stories get completed, they move it from one side of the room to the other side of the room. And so they start looking at metrics like how many stories are completed, how many stories are we completing per week. So it really depends upon, how detailed you want to be in the metrics, what you'll find useful. And that is all I have on metrics. Now, when I started teaching this class a long time ago, we actually had 2 full-time people teaching software engineering courses in the department. So when I first started teaching it, I avoided a lot of things which would normally occur in a software engineering course. So I really don't talk about methodologies, processes like that, because we had several different courses that already did that. But those people have retired, and so a number of times we offer software engineering courses far fewer than we like. And so as those people slowly retired, I added some material that should go on a software engineering course. And this topic is one of them. And if we're lucky, last year we were authorized to hire a new faculty position in software engineering. Unfortunately, the pandemic hit before we could make someone an offer. And so the campus then canceled that search to save money. It looks like they're going to allow us to try again this year. So hopefully next year we might have a new faculty in software engineering. So that's all I have for today. No, if we were teaching face to face, I'd be very not embarrassed, very guilty about having people come to campus to attend a half-hour lecture. But since none of us are on campus, I don't feel quite as guilty for not having more material.
I had to turn on my laptop for this.
Yes. And usually students don't complain too much about limiting the material on exam. So if there are no questions, we can adjourn for today and get back to doing other things.
So was the exam on Tuesday, or did you say we were having a review session on Tuesday?
We're having a review session on Tuesday and the exam is on Thursday.
Okay, got it. Thank you.
Yeah. Okay, have a good weekend, and looks like it might rain, so that'd be a nice change.
Thank you.